Let us move from two-wheeler now to something else, a e-rickshaw. Very similar vehicle, rho is same, CD changes slightly 0.44, area changes 3, the e-rickshaw area, amount of area that the air will cut will become larger, mu is same, weight increases like anything, because suddenly you are talking about 5-6 people. So, instead of 200 kg you are talking closer to 700 kg, 680 kg, that will make a very big difference. I am taking the same gradient of 5 degrees, and for sake of calculation I am saying the same pickup 20 seconds for a specific speed. Look at the force. If you see, the gradient force is now very large. Compare it with the gradient force that was required here, gradient force required here, you can see it on this screen, it is more like 160 Newton. Gradient force required in this is 600 newtons. Why? Weight has gone from 200 to 700 kilometer. Little bit of drag also has gone, because the area that it cuts becomes larger. Okay. Acceleration again plays a very important role, particularly if you want to do fast pickup up to 60 kilometer, it goes up like anything. It just keeps on increasing, depends on in 20 seconds what is the speed that you want to reach. If you want to reach only about 25 kilometer, it is not that bad, but if you want to reach 60 kilometer, it again requires a 600 Newton force. Here, even at 90 kilometer, you require only 250 newtons. Here you require much more, because again mass comes in, mass plays a major role. What about drag and rolling resistance? Rolling resistance is about 100, but if you see, rolling resistance is still higher compared to this, because once again mass comes in, mass plays an important role. Drag is basically the same between the curve that I am showing here for e-rickshaw and the curve that I am showing here for a two-wheeler. Why is the two-wheeler curve showing as if it increases rapidly? Because the scale is that it actually goes even at 60 kilometer per hour, it will go to around 100 newtons, not even 100 newtons, 60-70 newtons. Here it is only up to 60 kilometer, and you see it goes to up to only around 100 newtons. It is not a function of mass. It does go up a bit because of the area going up, but not considerable. CD also changes. Okay? So, this is the force for e-rickshaw. So, now I will actually look at that. What about the power? So, as a result, now you multiply it by velocity, all these curves, and what happens? And if you see this, the gradient power now is of course a function of velocity, and gradient power can be quite large. Gradient force was large, you multiply it by velocity, and at 60 kilometer per hour, it exceeds 3000 watts, 3.5 kilowatts. But at 25 kilometer per hour, still manageable. Okay. What happens to drag? Drag, which in the force did not look like at all anything considerable, here the drag force does increase, the drag force is going up, because velocity component has come up, but still not that large. Rolling resistance was low, now it is dependent on the velocity, so it is going up to 60 kilometer. At 60 kilometer, drag and rolling resistance are between 1500 watts to 2000 watts. But at 25 kilometer, if you see, rolling resistance is 500, drag is practically negligible. That is a big advantage. E-rickshaw is normally designed to work only up to 25 kilometer per hour, and at 25 kilometer per hour, drag plays practically no role. Acceleration plays some, but acceleration depends. Are you going to accelerate in 20 seconds? In e-rickshaw, it is not that important. Given this as compared to two wheeler, now let us look at so the same curve I am showing out here. Let us look at what is the implication. Let us look at the power. A gradient at 5 degrees at 15 kilometer per hour, 15 kilometer per hour, I require approximately 1.5 kilowatt. 1.5 kilowatt. If I really travel at 15 kilometer per hour, because I have done here at the curve is done at 3 times the velocity, you will have to actually see the 45 kilometer barrier. This is 1.5 kilowatt, including rolling resistance and drag. So, 1.5 kilo e-rickshaw motor, if you make it go up to 1.5 kilometer kilowatt, then it will be able to travel a slope. But normally slope is not allowed. We will take from torque point of view, it will become a problem. Power, it does not become a problem. And 1.5 kilowatt will just be able to carry out acceleration in addition to drag. So, 1.5 kilowatt, if I look at the acceleration power is 700 watts, there is the drag power and rolling resistance, together all of them is around 1.2, 1.3 kilowatt. So, 1.5 kilowatt motor is good, I do not require more than that. In fact, the motor that is used is around 1.2 kilowatt. As speed goes up from 25 kilometer to 30 kilometer, your things start getting worse. You will certainly require around 2.5 kilowatt. Why? Because your gradient force also will have gone up. More important, if you look at the acceleration force has gone up, and both these at 30 kilometers, both these points actually go up. Rolling resistance and drag at 25 kilometer adds only 600 watts. So, 600 watt is what you have to do. Up to 25 kilometer per hour, it is fairly safe. I want to again point out, force is related to torque, and this is where you will find problem. Force, on the other hand, if you see in e-rickshaw, the gradient force is very large. Because gradient force is very large, if I take climbing, torque requirement goes to approximately, this is 580 Newton multiplied by the wheel radius is smaller, 0.2 meters, it comes to 116 Newton meter. 116 Newton meter from a motor for a 3 wheeler low end motor, which is about 1.2, 1.3 kilowatt, will be very difficult. So, even a 5 degree slope, it will not be able to climb up, 8 degrees is impossible. E-rickshaw, by the way, is common only in India, they are not there in most other parts of the world. But they play a very important role in the country. Probably the electric vehicles, if you see, maximum number of vehicles are only e-rickshaw in the country. So, what does regulator do, government do? E-rickshaws are not allowed to climb a flyover, and e-rickshaw is not allowed to travel on a highways. They just do not have the torque. So, if you start trying to go over a flyover, it will get stuck, and if it gets stuck, it will block all the traffic behind, and therefore, they are not allowed. Even on a highway, it cannot speed up 25 kilometer per hour, which means it will be actually all the time vehicles has to keep on passing. Unless there are multiple lanes, it is going to be difficult. Overtaking always requires extra lanes, and you do not want the traffic to be slowed down in highways. So, on the flyovers and highways, e-rickshaws are not allowed. So, if you see, one is a limit of 25 kilometer, the second is a limit of the force, the torque. vehicle torque at 25 kilometer per hour due to, if I take all the three into account, acceleration plus rolling resistance plus drag is a slightly better value. If I combine all the three at 25 kilometer per hour, it is about 225 or 230 newtons here, plus about 100 newtons, plus about 20-30 newtons. So, you are talking about 340 newtons multiplied by 0.2, 68 Newton meter. 68 Newton meter then therefore becomes a target for your motor. If you look at it, 116 Newton meter you will not be able to handle, 68 Newton meter you may be able to handle with the right gear. We will talk about gear playing an important role, and therefore, for flat road, this is for flat road, up to 25 kilometer you can go. For a flyover you cannot do it. Therefore, as I pointed out, e-rickshaw are not allowed to ply on highways or climb. The key culprit is a large weight, 680 watts is what we have taken, kg, 680 kg we have taken. This much of thing climbing up is very difficult, highways is very difficult. Now, are you going to design a 1.2 kilowatt motor with 68 Newton meter? No, even that is not possible. Even torque of this size is not possible. So, all these vehicles will have gear. Now, gear is there in IC engine also, gears will always be there in electric vehicles also. We will discuss this gear in detail later on. The gear in IC engine, in a petrol engine, is a gear where gear ratio can be changed. It is a changeable gear. You move gear from one point to another. Because a petrol engine or IC engine can only allow so much variation in speed and so much variation in the force. So, you make a changeable gear. Now, changeable gear, what would it require? It would require a clutch, then gears has to be changed, gearbox has to be there. That whole thing becomes complex. Electric vehicle on the other hand, motor can actually take whole range of velocity and still RPM and still have a fairly good efficiency, and it is possible therefore, to also get the fairly large differential torque. So, generally electric vehicles uses only fixed gear. Now, fixed gear of course is a big advantage. I do not require clutch, I do not require changeable gear. Changeable gear is much more complex as compared to fixed gear. But it means that I have to design one gear. And what does a gear do? The role of gear is very simple. It multiplies force or the torque and it divides the RPM or the velocity. It multiplies torque, divides by the same extent. So, if I take a gear ratio of 10, my torque available from a motor will go up by 10, but my RPM will go down by a factor of 10. Now, I can design a motor with large variation of RPM and therefore, even if it goes down, I still can drive at a decent speed. So, for example, in a vehicle like a e-rickshaw, we will talk about this again and again and again. The gear ratio typically uses 10 Newton meter. Now, for 10 Newton meter, the slope time instead of 116 Newton meter, I now require only 12 Newton meter to climb. Even that is tough from a 1.5 kilowatt motor. But if I look at traveling at 25 kilometer constant speed, 68 Newton meter, you divide it by 10, 6.8 Newton meter, that is easily doable. So, in fact, electric vehicle e-rickshaw motors are designed approximately 1.2 1200 watt normal power, peak power can go up to closer to 1.7 1.8. So, it will take care of all these requirements. Torque, peak torque can go up to 7 Newton meter, and with the gear it will give you 70 Newton meter. So, that is how it is designed. We will talk about gears more in another chapter. We will specifically talk about gear. So, the term used for gear, gearbox, clutch, everything is in a petrol engine, IC engine is transmission. Because you have a fixed gear electric vehicle, your transmission is very simple, a simple gear with a fixed ratio. In a other vehicle, in a petrol vehicle, it is far complicated. Now, this however means that motor has to be appropriately designed for wide range of torque and RPM, and that is what we are going to focus on. Now, having done this, let me come to a small sedan, small four-wheeler kind of vehicle is like Mahindra E-Verito. I think you must have heard of Mahindra. It came about 4 or 5 years back. One of the first electric vehicle that came into India is E-Verito. In fact, I own one such vehicle. I have been driving that for almost 4.5 years. It is a vehicle where 4 people sit comfortably, 5 people can sit, no problem. Back seat 3 people can sit, 5 people. It is a vehicle with a not very powerful motor. Is designed to only travel at certain speed. Maximum speed that it travels about 70-80 km per hour, 80 km per hour. Above that becomes very difficult. It does not go to 120, 130 km that many other vehicles go. It has a certain torque. So, climbing becomes slow. So, this is the vehicle. I have taken the motor weight to be 1200 kg. This weight includes passenger weight, which is a little small. If I put 5 people, then it can't be 1200 kg. It will go up. So, one has to take that into account, but I still will do the calculation at 1200 kg. Gradient is 5 degrees. So, it is about 800-900 kg vehicle with 3 people normally it will be 1200 kg, or 4 people it will be 1200 kg, 5 people will become extra. The air density remains same, the drag coefficient is 0.35. If you look at the drag coefficient that I yesterday talked about, you will see the 0.35 for a sedan kind of vehicle, compact sedan. It is a compact, not very large vehicle. It is like your little bit like your ambassador vehicle of yesteryears. Area is larger, 2.5 square meter, even larger than the 3-wheeler. What happens to all these forces? Look at the forces. Gradient of even 5 degrees is about 1000 newtons. Force is of course constant with velocity. If I want to accelerate in 20 seconds, suppose I want to go to 60 kilometers, well, it is again 1000 newtons. But if I want to go to 90 kilometer, it is about 1500 newtons. Force goes up quite a bit. Look at the other 2 components. Compared to these 2 components, they look very small. Look at the rolling resistance, just under 200 to begin with. As speed goes up, it goes to up to 200 newton. What about drag? Well, even 50-60 km per hour, it is still under 200. At 90, it goes up slightly to around 300, 350. So, in a normal operation, it is only going to be rolling resistance and drag. I won't accelerate, I won't go to slope. So, the force requirement is not that high. Even if I add everything up, it is about 500 500 newtons. But if I take the gradient, it is large. So, it has to be designed to take that into account, and if I want acceleration, that is going to be large. Let us look at the power. Look at the power curve. As I told you, everywhere a V term gets added, rolling resistance therefore continues to increase. At 60 kilometer per hour, rolling resistance is still going to be around 3500 watts, 3.5 kilowatts. Drag is going to be even less. At 60 kilometer, look at 60 kilometer. At 60 kilometer, what happens? Gradient power, I require, well, 60 kilometer is actually 20 kilometer, I require about 5-6 kilowatt. Acceleration requires about 8 kilowatt, plus I have to add the other two. So, look at it. If I if I want to travel at 60 kilometer and I want this acceleration plus rolling resistance and drag, it will be 6 plus 2 plus 2. I require 10 kilowatt. Even for gradient, I have 6 kilowatt plus 2 plus 2. So, 10. For acceleration at I require 8 plus 2 plus 2. So, 12 kilowatts. So, 12 kilowatt motor can make it comfortable up to 60 kilometer per hour. On the other hand, if I want 90 kilometer per hour, things change. First of all, if I want a fast pickup, I require almost 18 kilowatt, and my gradient also requires 8 kilowatt, plus drag and rolling resistance is also increased to about 5 to 8 kilowatt. So, I will require, even if I do not want to accelerate that fast, I will require 8 plus 5 plus 5, about 18 to 20 kilowatt motor. Of course, I still will not be able to accelerate fast enough. Now, when do you need acceleration? Of course, during the pickup, right in the beginning. You also need to, when you try to overtake. So, if you want to travel comfortably at 80 kilometer on highway and want to be able to overtake, then you require 18 to 20 kilowatt motor. Otherwise, 14-15 kilowatt motor may be enough. Now, so that is what you must keep in mind, and I look at therefore again torque and force, acceleration, 20-second pickup, gradient and gradient dominates. That is what it is. It is the pickup for the torque, both things dominate, both these dominate. Fortunately, both of them do not come up together. So, one of the two will be there. So, for the torque that you require, torque required at 5 degree slope at 60 kilometer per hour, when I have computed, it is 300 Newton meter. It is a 1000 radius is about 0.3 meters. So, about 300 Newton meter. So, you require 300 Newton meter, you have to choose the appropriate gear ratio to get 300 Newton meter. Of course, you have to also require at that point some force due to the rolling resistance and drag, you have to add that, but it is 300. So, okay, you may want to go 330, 340 Newton meter. That is a kind of thing that you require, and if you choose a good gear ratio, you require only that much. That is the torque and force, and by and large at 60 kilometer, that will also give you sufficient acceleration. If on the other hand, if I take a speed of to 50 kilometer, up to 50 kilometer, 10 kilowatt drive is enough. I just shown you for 60 kilometer, you require about 13 kilowatt. For pickup, 10 kilowatt is enough, a slower pickup. So, 10 to 13 kilowatt is required, and in fact, E-Verito I think has a motor which is about 12 kilowatt or something like that, not much more than that. But if you want to travel at high speed and do all kinds of things at 70 kilometer per hour, you require about 18.5 kilowatt at 70 kilometer per hour. Let us look at 70 kilometer per hour. At 70 kilometer per hour, you require higher at 70 kilometer per hour. you require higher, both for acceleration, gradient. So, you require about 15 to 18 kilowatt. At 80 kilometer require, you suddenly are requiring 25 kilometer per hour. Per 80 kilometer, you require almost 15 for acceleration plus drag and rolling resistance, you require 25 kilowatt motor. 15 kilowatt may be enough if you are not willing to have very fast pickup. So, the new E-Verito are about 25 kilometer watt motors. It all comes from these numbers. And what are these three numbers? There are only 4 quantities. First is rolling resistance, gradient, slope and acceleration. And the parameters that you need is only rho, CD, area, mu, weight. Weight plays an important role, and of course, gradient can play an important role. Speed up to 90 kilometer per hour, you suddenly require 30 kilowatt for pickup. 20 kilowatt may be enough, including for slope. Slope, of course, you will not go at 90 kilometer, you will go at 30 kilometer per hour. So, if you have a 20 kilowatt motor, it will give you a slower pickup, but rest it will work. But 90 kilometer per hour, this kind of stables down. What about if you want to go to 150 kilometer per hour, like in Europe? Whole thing will shoot up. More like 60 kilowatt, 70 kilowatt, 80 kilowatt you may be requiring. In fact, it will be a good homework problem. You take the same sedan, make it work till 150 kilometer per hour. Calculate each of the 4 components. Please note down and send it to me. I will add this as a homework problem, that each of the rolling resistance, drag, pickup suppose you want at 90 kilometer, gradient you want to travel 5 degrees alone, but at 30 kilometer per hour, because 90 kilometer is your maximum speed. What is the forces and what is the torque required? You will say torque also will significantly increase at 90 kilometer per hour. Gradient torque will not increase much. Gradient torque is flat, but at 90 kilometer hour, if you see this force at 90 kilometer per hour, it is 1500 plus 200 plus 300, you require almost 2000 multiplied by 0.3, you require almost 60 Newton meter, 600 Newton meter. So, it is actually much more. So, you have to design your motor appropriately. So, I think I come to a very important part. A drivetrain is to be designed to provide adequate force and torque. Force and torque is very important at different speeds. To overcome drag, rolling resistance, gradient resistance, also provide the right acceleration pickup. If you can't have sufficient torque, you can't speed up, you can't go up to the gradient. Torque plays a very important role. Similarly, adequate power at different speed. Torque and power are two different things, they are related to all force. The force is multiplied by the wheel radius to give you torque, force is multiplied by another velocity term. So, power, speeds become very important. Torque is somewhat independent of speed for the different kind of drive. Having done this much, we have actually done for 3 vehicles, we can do for more vehicles, we can do it for a truck, we can do it for a larger vehicle, but it is pretty much similar, and there are some homework problems and other things where I will be actually talking about this. But there is a new task that I want to define for our next set of lectures. So far we talked about force, torque, power and speed, 4 important parameters: force, torque, power and speed. Force versus speed, torque versus speed, power versus speed, 4 parameters we talked about. Next, we are going to talk about energy.